السلام عليكم ورحمة الله وبركاته. أسعد الله صباحكم بكل خير. يسرنا أن نرحب بكم هذا اليوم في المحاضرة التي سوف يلقيها البروفيسور نيكبين، وهي عبارة عن approaches in recommendations and development material standardization. Before we start, before I hand over the mic to him, I would like to go quickly and briefly through his CV. Professor Nipkin has worked at the Imperial College since 1979, and currently he is he's holding a research chair in the Royal Academy in UK. Professor Nipkin's involvement as an executive chairman of Astm, ASME, BSI, and European standards. He has published over 350 refereed papers in the areas of the fracture mechanics and the structural integrity. I won't take much from his time. I would like now to ask him to come forward, please, and the mic is yours.
Right. I'd like to first thank the chairman and also Sasso for inviting me to give this lecture. I hope I got a general description of what I should say and what I should talk about, and knowing Sasso as a standards body, and all standards bodies across the world are very similar, I decided that I would try and come up and give you some descriptions of our own experience in various standard bodies, and to see how that helps Sasso, for example, to sort of have improved approaches in developing standards. So excuse me if some of the areas are not of interest to you, but I'm trying to present it as a general approach. In fact, the title on approaches and recommendations also had added to it SEN, ASTM, and a number of standards bodies. So my hope is that within the next 30, 40 minutes to give some outlines and maybe have some discussions at the end to see how that approach can be relevant to your interests. So to begin with, the important need for codes of practice, standardization, etc., has been in industry for thousands of years, effectively. And I point out to one word, ISO. ISO, in fact, is the overall standards body, international standards that everyone is familiar with. And it comes from the word isos, equals in measurements. So going back to a long time in history, we have had to have levels of standardization for people to interact, to trade, to deal with. In fact, World Trade Agreement has these measures which needs harmonization of work between different groups, participation of this work. Anyone who participates, that means they can share that information in a better way and use this on an international basis. So the WTO and everybody else, in fact, do support to reduce these technical barriers in international trade, encourage support for fair trade, and have definitions which are very specific to every individual aspect of life that has interaction, to produce openness, transparencies, impartiality, and relevance and coherence. All these words are descriptive, but they have to have some meaning in written words for every different type of work. But the objectives are similar all through. So types of standards that we talk about generally are such wide variations that one has to at least try to separate these areas, and that is, one is the actual measurements, definitions and classes and grades and ratings. These are type of standards that exist in work. Test methods and recommended practices. So a number of times people need to test their equipment, their materials, their things that they're designed in order to see that they are, for example, safe, they can operate for the period of design that they're talking about. And quality of standards really goes into actually the trade and selling and transferring materials and goods to people. And that has to have a minimum level of quality. Now, this has had to improve because on an international basis, an understanding of what you're buying are based on what standards are specified in that, for that particular material. More importantly also is that nowadays especially, and it's getting more and more, is health and safety. And health and safety are issues to do with insurance and legal aspects of if there are failures in a component, if there are failures in, or if there are things are people are affected by issues to do with the material, with the industry, and therefore health and safety is a very large area of that has to be considered. And building codes, obviously, that goes to a wide area of structural developments to make sure that the actual building is safe in operation under extreme conditions. For example, if you have earthquakes or floods or any of these factors, all these have to be considered in standards. So I'm trying to touch in 30, 40 minutes a whole wide area of standards and try to at least clarify, well, for myself and for everyone here, to see how we can make use of these areas for our own work. Now, there are some national and international standards that historically have been well known because they started in the early days and they have developed, and many countries that come along and they have to deal with standards usually don't have their own standards. So initially they would have to follow certain standardization of experienced groups such as British standards, German, the French code for the nuclear work, for example. Chinese National Institute of Standards now are very seriously attempting to completely have their own standardization groups independent of these other bigger US concerns. Also, Japanese Standards Association, they follow basically, for example, ASME, but again, they will adopt and change these standards because they're not going to repeat experiences, but they will adopt and make adaptations to the standards according to their own local needs. And obviously, I think the main users of international users of standards are the US groups, Astm for testing materials, ASME for assessing industrial components, and measurements, NIST for measurements. So that's the list again. And I will try and give a few slides for these different ones and just give you some idea of what their approaches are. Essentially, one could argue that they are similar in approaches, but certainly the way they adopt and they work to produce standards are different. Some of them are much faster, some of them take many, many years to develop, and some are more difficult to even try to change. But we need to take that into account. And I will mention some words on that. So if we go back to the basics and look at what we need to do. We need to improve measurements, metrology, to understand and actually get specific values for various areas of aspects of life, to determine dimensions, quantity, capacity, etc. And this goes back, this just goes back from the Egyptian times when they were developing and building, at that time measuring. Now I'm moving on towards, I call this macro because these were measurements that they were capable of doing at that time, to the level where we are now able to measure things at the nano level and even subatomic level. And all of these are appropriate to industry. Electronics industry is in needs of this, surely. Most of the work and measurements and techniques are in the sort of macro level of applicability. But the equipment that these days we get for our research laboratories, electron microscopy, or any other techniques, are able to do much better measurements than, say, even 10 years ago. This means we have to have standards and methods of calibration to be able to measure at that level. And there are institutes such as, so these are just give you an example, basic SI units. In fact, SI units came into effect only after the war because of the realization of a globalized condition where people needed their own, not just their own methods of measurements, but an important standard internationally accepted. Most countries accept this still. In fact, the US is one of the countries who doesn't still follow this 100%, and they paid for their mistake when they sent a satellite to Mars, and somebody had calculated in terms of metric units and the other in terms of miles, and they had problems, and the satellite crashed. So, just this has made a very important difference to international trade, international collaboration. But one of the early institutes was the National Physical Laboratory, and NIST was later on. But in fact, NPL has been around, National Physical, in the UK for over 100 years, where they identified the importance of this international trade and measurements to do with that. And in fact, even at this stage, a number of basic measuring tools are held at these institutes, and people refer to those as their basic means of calibration measurements. And they're independent centers, in a sense independent of government, but they do the work that, for example, both industry and government needs. In terms of doing the actual research work, so any standards, we must understand, goes back to fundamental research. You understand the fundamental research, you characterize it, you standardize it in a simplified way, because industry is not going to do research every time. They just want to know, am I safe? Am I doing this right? That's it. But all this research work goes into how industry and universities and research institutes go about developing standards. And this is part of what we do, for example, when we interact with industry and standards institutes. We try to not ask the question that you should do this and that. We just say, how does this work? How does it affect the outcome? And that recommendation goes to characterizing and standardization. Obviously, the most important is probably time. The atomic clock, I think now they're trying to improve on that. 1 in 20 million years, of 1 second in 20 million years. But time is an important basic standard that everybody uses every day. So that's, there's no question or argument about this. NIST, for example, considers legal metrology, weights and measures. Look at the amount of trade that is related to this. That's in 1996, even 10 years ago. We can probably double all this. But in terms of actual trade of foods. Yeah, sorry about that. So these measures influence the economy, and everybody is aware of that. Is that all right? And we are all aware of this, and there are clearly standards that should be done, not just recommended in industry for it to be able to sell this material across the world, follow safety rules, and these are basically backed also by government. And government makes it, stipulates that certain conditions have to be followed following these. Industrial metrology, functioning measurement instruments using industry and production and testing techniques. So measuring instruments have their own level of standardization. They've got their own level of calibration. The quality and measurements that we do these days compared to even 10, 15 years ago, and the quality assurance that is needed, for example, to have mass production of equipment, for example, even motor cars, you can see the differences that have had on industry, the production that we have, for example, these days compared to 20 years ago, and the quality of the car that comes out at the end of it, is all to do with following very clear, specific set rules of standards from the local manufacturers producing the parts to putting them together, to measuring and having the quality assurance. This level of safety would not have existed at the rate of production that we have now. We're talking of such rapid production improvements and increases and transportations that without standardization it would be impossible to try and think of improving trade. On materials testing and metrology, I think materials this is the areas of interest to myself, and there are one or two important standards bodies such as Astm, American Society for Testing, that I'll talk about. But going back from testing laboratory materials or actual, in this case, is a neutron measurements of, for example, of residual stresses in a component, or even actual machines themselves at various levels. All of these are followed by specific levels of testing from the material level, i.e. every individual part of material that has to be followed needs, the development, the production of the material needs standardization, the testing and the behavior and the characterization needs standardization, the putting together of that equipment needs standardization, and the actual behavior and the response of that equipment. So all these various levels have to be followed industrially, and whether they improve it in these kind of equipment or whether they improve it online fast production, it would be the same thing. Except the only difference is the level of accuracy that you specify. For example, if you follow safety codes in nuclear technology, there is absolutely no error allowed. Of course, there will always be a chance of failure, but you must not allow any failure of any part. Therefore, the standards for the nuclear industry are extremely high. We would be talking of failures not occurring in the 10 to the minus 7 chance of failures, which is 10,000, 100,000 years. Now, we know ourselves that even doing all these, following these, we do get failures in the nuclear industry, and the only way that forces people to rethink how they have made a mistake is going back to the standards, and that's what, for example, Japan is doing now in following the tsunami. They're going through every safety aspect, checking what part of the standard was missing, and improving it. So this is telling us that standards is not a rigid document. It's a developing, improving document. For example, in the tsunami failure of the nuclear plant in Japan, they had in fact calculated for a 1,000 years possibility of an earthquake at the level of the 1,000-year level. And that's the standard that all the nuclear bodies have to have. So they knew that even if they have the strongest earthquake that could occur in 1,000 years, they would make sure that the plant is safe. But they never considered the possibility of these two acting together and a summation of a tsunami plus an earthquake affecting a flood, which is an indirect way that produced that failure. Now they have to sit and rethink, and that improves the standard the next step. Now, clearly, we are never going to be able to be 100%. But the experience that has been built up, not just in this case, but in every industry, has shown us that by improving things, we can now be much more confident on our equipment. These days, you buy a car, you can switch it on and never even look inside the engine for maybe 3 years and return it, and it runs perfectly. That is the difference that effectively standards have made. Now I can give you examples in the food industry, in the transport industry. All these are really the same concepts of trying to improve our standardization. So metrology, design and runs, and measurements and calibrations and tests. This is the person who really takes the information from the engineer and the technician and decides what are the conditions, what are the safety limits, what are the levels that have to be attributed in the standards. I'll start from the top effectively and just give you some examples of these standards bodies, because they're all really, in most cases, they're voluntary. When we say voluntary, they get together groups of interested industrial parties or industrial or countries who sit together and say that we certainly need for this particular material or component a method of standardization. We need, for example, for testing certain materials or steels, standardization. So it starts from a group of interested parties, and that usually covers industry. And when we say voluntary, these are all voluntary because they will not enforce, but they will produce. It is for the government or the companies to adopt those as legal entities. So ISO is an overall standards body, of international standards body, and it really needs to get the involvement of all countries and signatories of all countries. So you can imagine this is the toughest step to get through, to get every country to agree to a certain condition. But clearly they know that it works because all these documents which follow an improvements, improve consistency, improve products, processes and services, and effectively improve trade. The business strategies that people do follow has improved in the last years because of ISO's involvement. Whether people like it or not, whether they believe standards is forcing the industry to be more expensive and less cost effective, that is not an issue. The issue is that overall world trade has improved, safety has improved because of these enforcements. So any standards bodies needs to understand this, that there is absolutely no argument or discussion about economic feasibility of a project and the safety and operability of the project. That has to be separated completely. They're an independent, non-governmental, so you can see it's a membership organization of the countries, and they're the world's largest developers. When they say developer, most of these standards in ISO are really starting from national, well-known national standards bodies, in ASTM, in BSI, ASME. They are put towards the to ISO as a document, and it's usually a technical assessment document at an advisory level. It takes maybe 4 or 5 years for that document to get into the hands of people who are first interested, because you could send these documents to everybody, and especially these days with emails, and the people bin these. The important thing is, when it gets to the right people, they will come up with comments and statements, and because they have interest in that. And once it goes through that phase, it takes another number of years to get interested countries to follow and be signatories to that. So looking at this position now, they're talking of some 19,000 to 20,000 standards that are available under ISO. So you can see what a wide range they would cover. This is again really follows up from that. It's really to get the standard organization and produce standard documents which are acceptable to all the countries. And this is really the very difficult task of getting it through so many countries and getting the countries to accept that standard. Once it's accepted, then it's fairly easy, because it's usually going through government is a legal entity at that point, and they can adopt it as a legal entity. Again, we can separate these standards in terms of whether they shall be done. For example, there's no enforcement, there are suggestions, recommendations, or whether these codes of practice there should be shoulds on that, or whether they are actual full implementations with certification level. So people will want to voluntarily adopt these first two, but if they need to have certification, and this is where these days industries need that, because the supplier and the buyer need to know that there's a minimum standard. That means some independent body, such as ISO, such as UCAS in the UK, for example, will come and give a certification at a certain minimum level of quality. And that is usually followed, it's legally binding. For example, when you have insurance cases or problems with failures, and these are massive, it's a very big industry, insurance industry in the whole range of trade that people are facing and challenging every day. And that even though the ISOs are supposed to, standards are supposed to improve and reduce that, but there's still is a very big cost on industry that they have to face, and they have to be careful not to spend too much on. Now, we go back to what their scope is determining what this industry needs. That is the important thing. Determining what the national standard has. So if your national standard doesn't have that, the national standard could decide that this could be adopted. Determine what consensus, what agreement is between people. Clearly, there are no clear rules on anything that one person would stipulate and another would agree 100%. There has to be a consensus. That consensus is dependent on the knowledge, the technical knowledge that exists. Your technical knowledge in your country, technical knowledge somewhere else, has to match to some level, at least in the standards bodies. Because if that doesn't exist, i.e., they don't understand each other, you cannot use a standard in a blind fashion. You can say, okay, that standard exists in ISO, I will bring it to the country, I will apply it to this industry, but we don't know really the details of why this is happening, why it's telling you to do this, this, and this. These questions only come from education. The education that needs to be done is usually done by the standards body. They have a group within the company of educating people, educating industry, disseminating information, and that is a major group in all of these standards bodies. So effectively, by planning, doing, checking, and then acting, this simple circular argument, one is able to come up with at least a basic standard. Now, ISO's approach, I've put it in terms of just number 1, 2, and 3. So a new standard is proposed relevant to a technical committee. So that these technical committees are wide and varied, and they get together because there's consensus, there's agreement that there's a need. Then the working group of experts discuss it. These experts are the ones who are doing the research. They're not necessarily from industry. The draft a technical committee document and share it with ISO national members. So that's what the technical assessment exists. And we're talking of these going through many years in terms of development. And you expect comments from experts in the field. So you can see how focused it becomes. You're focusing on every specific issue, every specific standard, and therefore you know that, for example, there are 50 people across the world who have this information and understand this. You have to get them involved, and more difficultly, on a voluntary basis. Many people these days don't have that time, and I think this is a difficulty that we find, from my own experience, that some of these standards, that's why, again, this is a word of warning, that, for example, if there's a paragraph stipulating a certain thing, but it does not refer to the actual work properly, the reader, the user, does not know why he has to do this specifically. And if it's not validated, if the work is not understood, it's not clear, it's like following a blind route and following a black box. That is the area that we have to be very careful on. And in fact, you can imagine some standards do have certain recommendations which may not be absolutely right or relevant or safe. So it's up to the local national body to be able to check these according to their own interests in their own country. And then maybe get back to ISO and say, look, this doesn't match, or we disagree. So in the midst of a voluntary relationship, you're getting now people to be involved, to worry about the quality assurance of the standard itself. So once this is reached, you have the first draft, and if this is approved by member vote, that means across all the country members, you can call this an ISO standard. And that's really the beginning, because improvement in ISO standards has to continue. So they have committees which carry on continuously. They're looking at improvements in developments all over the world and feeding back into ISO, and that allows us to go back round again. So certification, as I said, is the important issue. And more and more you can see that trades, you have stamps of certification from ISO for industry to have minimum approval. And that has been a very positive aspect. Now, I'm not going to go through details of how you register and how long it takes to get. You can see how long these things take. Inspection, surveillance, audits, rectification audits. All these factors are costly to the industry, and at least in the short term, are costly but important. And if this is not done properly at any stage, failure to do it means that really the actual application is not going to be appropriate, is not going to be good for industry. And as this is said in ISO, you can say that this is now beginning. Certification is the beginning of the whole thing, because managing what is happening on a regular basis as an internal issue and from someone independently checking this needs timely and costly updates and improvements. So surveillance, auditing, external registration need to be in place in a proper fashion, and that is done again by the national body in the country. The benefits, I've been talking about all these benefits, and in fact all of these affect at the long term, your competitive advantage, because everyone has to follow these rules. They are now in an equal playing field. The quality of service, better management, engagement, and communication with society as well as their own people. Repeatability, accountability, all these factors I'm sure you all know a lot about, but it's worth putting it in context in terms of how a big standards body sees it. Now, the benefits, for example, they're talking about generally is 75% improve their level of customer satisfaction, 75% boosted their operational performance, 70% acquired new customers, and in the overall run, cost and savings are achieved. So it is really a benefit for example, SASO to build these areas of improvement, checking, optimizing standards for the country, and auditing and certification, I'm sure, to be able to improve long-term trade and performance. And there are obviously best practices. All this information, your documentation to do with ISO is massive. And all is coming from these committees dedicated to developing these various areas of all these experts in the world. I mean, I guess one way they do it is they always invite them to very nice areas in the world, for example, meeting in Hawaii, or get everyone together in a relaxed atmosphere for them to be able to contribute, which helps, I guess. Right. I'll jump to ASME. ASME is an important one, especially in pressure vessels technology, and a lot of the industrial components have to follow ASME rules, and in fact they've adopted ASME rules in most cases across the world. Some countries, such as Japan, have adopted ASME rules, but then they have changed the standards slowly, and that's taken them many years to suit their own industrial purposes. But their first code of practice was in 1940, and this has grown to 600. The difference with ASME is that it's not just pure testing or pure measurements. It comes into the actual operational standardization, assessment and standardization of the components, safety aspects of the components, to make sure that whether you're designing a new component, you're following ASME rules, whether you're operating it at a certain level, you're following ASME rules, especially in the high temperature and high pressure areas. So they have for that, as I said, dissemination of information, they have the largest technical publication, publishing operation in the world. They have numerous conferences, which I'm sure you're familiar with, where they get everybody together discussing not the actual specific documents. They are in separate committees and they're different groups, but actually looking at the research which leads to improvement in the codes of practice. That improvement in codes of practice clearly takes a long time. In our area, we are involved in fracture mechanics, which is really looking at components failing, either whether they're metallic or, for example, structural components, concrete components, composite components, going to failures in aero industry, turbine blade components. All these, there are rules available for these, and the fracture mechanics is a new aspect, because you're aware, I'm sure, if you have a welded material which has some cracks, you tend to take it out without real assessment, because you either repair it or you take it out. You don't consider assessment. In trying getting ASME to understand and put cracks route as an assessment technique has been taking under high temperature area for many years. We're still trying to persuade committees, because they assess the component as a clean entity at high temperatures. They don't assume that there's a crack. Now, if there is a crack, which we know there is a crack, because now we can measure cracks up to microns, that part does not exist in design codes of ASME under high temperature. Therefore, for the last 5-10 years, they have realized that this is an important issue, and it's taking so many years to try and get these parts into ASME, and they're very conservative, and rightly so, because they're linked to nuclear plant, and they want to be 100% sure that any changes is going to be in the right direction, either by reducing conservatisms or making sure that safety exists. So what I'm trying to say is, to get ASME to change their ideas and their views and their documents is a very difficult and hard route, and only industries who are really keen and interested in pushing these ideas through or wanting these changes made have any chance of trying to do anything. In this case, EDF Energy, which is in the UK, was the old British Energy, and they have their development of fracture mechanics codes at high temperatures is a big player, because they use this crack methodology of assessment in their own industry, but internationally it is not being used. So ASME is trying to adopt these ideas. The routes, obviously, in some areas is much easier, in some areas it's much more difficult. And I've given you the worst route, the most difficult approach going through ASME. But look at their level of why they're internationally accepted, because their publications, their technical journals, their periodicals, their conference, all of these are ways of making sure that first they're online, second, everyone knows about it, third, once everyone knows, they will, if one country adopts, industry has to follow the same thing, and therefore it's a natural process of following those standards rather than saying, oh, I'm not going to follow this standard, I'm going to use my own, because you're in the minority. And this improvements of training education is a foremost area that they have to work on. Short courses, company programs, global training, technical seminars, all of these can be miniaturized in a country to be able to get the industry to understand and learn how to apply and use standards and codes. Now, the future, for example, ASME doesn't just look at what codes they have, they look at what areas of development, for example, exist. And I'm giving you an example in this case, because that's their strategic approach. And they're being directed by industry that is interested in that. And they're looking at multidisciplinary codes for engineering and standards and conformity. In this case, the traditional area that they have is pressure vessels and power, but now they're looking at, for example, bio and pharmaceuticals, homeland security. There's a major area of safety and standards aspects that they're working on. Water management, because they know that this water management is a very sensitive issue in many areas of the world, and obviously computer safety and technology. So you can see how an organizing body is able to shift focus if they see developments internationally. This is international. And really, no standards, international codes, accepted codes exist in these areas. There are company codes and local codes, but nothing major. So their approach is quite important. Just quickly looking at British standards, and they're one of the first. In fact, they do state they're the first body for standards, 1901. The first BSI 1 is in 1903, and they have a certificate demarcation, like saying that you've reached, the industry has reached a certain level, from in 1926, and they effectively founded ISO. So if we look at the history and how it's developed, ISO is now being fed quite a number of standards into ISO from British standards. So the British standard view is now prevalent in ISO. So we were talking of 95% of standards of UK going into ISO. So you can see how one country can influence the standards body internationally, and whether that affects improvement in trades internationally, we're not sure. But because of their historical standing, and because of obviously probably the English being as the basic language, this is quite an important understanding of how ISO is able to stand confidently. In fact, if these standards are internationally adopted by all the signatory countries, that means it's really British standards which is involved in that. So in 2014, they've had 2,000 standard publications. That means it's continually adding to this level of complexity that we have in trade. And these are just various examples of British standard development. And this is how they work globally in terms of linking Europe and Africa and US. They have effectively their ISO and BSI influencing different countries in how to present their goods or develop their industries or how to follow rules. So they need a very big team to be able to have the legal, personnel, financing, marketing, etc. of their standards. So it becomes a major, in terms of inspections, certifications, all these aspects means that developing the group is an important part. They have customer training in 110 countries. They run programs all over the world, and they are now looking at, for example, security, environment, and management projects. I realize that we don't have very much time, but I was planning to finish about that. So, system awareness, implementation, auditing, business processes, in-house training, all are important issues. European SEN standards is also trying to follow a similar thing, but try to cover at the European level. Again, they share information with BSI, with ISO, with the other standard bodies, and they really have the same policies. So I don't need to go through that, but otherwise to say that you have now 33 countries, if they follow SEN, they become an important force. And in fact, they're looking at all ranges of IT, food, healthcare, machinery, materials, etc. And they're available in 3 different languages, and it doesn't conflict with any other standards. So they follow in agreement with these other standards. And development is in terms of consensus, openness, national committees. Similar, they follow ISO. I'm not going to expand on that. And I will leave these set of slides for anyone who wants a copy and take it. So we don't need to go into detail. But all these steps that we go through, they have to follow meticulously, and it takes many years to do that. And this is moving from company standard, informative, recommendations, and mandatory. So you can see that levels of standard, technical to regulations, are all followed by these groups. And that is what everybody sees everywhere. When you have a CE on the material, you know exactly what you're dealing with. And that is the end objective, to improve that trade. ASTM is an American standard for testing, and that is very important because materials, all range of materials, composites, concretes, metals, alloys, all of these have to be tested according to and have to be characterized according to standards. In fact, they are the fastest developers of standards, and very quickly, because they have consensus within the company itself. They're a private company because US stipulates that this kind of standards should be under a private group. They produce this with industrial approach on a voluntary basis, and then they sell these standards. And in fact, they can have a turnaround of 1 year of testing, developing it, and putting it into standard, a certain specification. And that is one route that many people industry goes. And this is really test methods, test practices, standards guides, classification, and terminology. Now, for example, in 1901 was their first technical standard, but latest developments, for example, in terms of portable testing of large pieces of steel in structural conditions. Role of government, clearly, there is little to argue about. Government needs these bodies, and they need to be able to establish this locally so that the private sector and the government sector follow these and they know that what levels of work they're dealing with, both nationally and also how they, to help them internationally to improve their trade. And it needs, that this produces transparency in the market, harmonization, agreement and approach, and reduce conflicts in terms of trade. The last thing is, one or two slides, is that some of these, there are committees which produce recommendations for standards, and the most famous one is this 1982 set up by G6 at that time of an agreement in Versailles of testing materials. And these testing materials, because they knew that the materials are getting more advanced and improved, committees range in this group. These are the committees and the type of materials that we're looking at. I don't need to go individually, but anything from ceramics, corrosion, computerized data, etc. These committees come up with recommendations to standard bodies, to ISO, to Astm, etc. And they're very important because you have the experts who voluntarily get involved in there. I'm managing one of these, and they help the standards to be improved annually. So just to conclude, all of these we've discussed, I've mentioned to you, I'm not going to repeat, but I think of the most important of all these is this last part of education and dissemination of your codes, to get people to understand why they need it, how they need it, why they should follow it, and why they should not disregard it. That education is the hardest part to do, I think. A lot of this is available. It's the education that's very important. So I will stop at this point, and if there are any discussions, any questions, I'm happy to answer you.
Okay, we'd like to thank you very much for this informative, valuable presentation. And now it's time for questions. If anyone has a question, can you please hand his rise up?
First of all, thanks, Professor Niyekbin, for your time and joint work with the SASO. As well, I'm very thankful for our colleague, Dr. Mas'ad, for his effort. Just if you could elaborate, Professor, on the evolution of the standards themselves, starting from the product to the process. And I think they are talking now about a third generation, which is something about maybe the surfaces or something you could, still not materialize maybe in a good, in a very clear way. If you could elaborate on this one, this would be appreciated.
The last bit I didn't...
the third, generation of the standards, which is going beyond, beyond the products and the process itself. They named it in this way, and I'm sure you know about it.
The documents are not set in stone. And information, usually from universities, from research institutes, are continually coming up with new testing, new ideas, new methodologies, and new measurement techniques. This feeds back into committees which are always available. They don't close these committees that originally produced the standards, although the members change, but they do, these ASTM and ASME and all, they keep these committees live all the time. So this feedback into the system means that somebody is responsible for adding changes in at the third level, improving the standard, and then going back through the process of voting, etc. And this takes clearly some years. It's not a straight away, because you have to get acceptance. If you want to change something, even one word in a standard, it takes a long time. So usually it has to be fairly substantive for these committees to be able to recommend that we should now go around the next step. ASTM are the quickest on this, because during 1 year they have 2 meetings for most of these standard committees, and then they have voting of members, of experts, and comments on changes. If one person says he disagrees with this, he has to be answered before anything moves forward. So all you need is one disagreement. So this is what I understand from you. What happens on the third step is that these standards are live and they should continually be improved. But they go through the same process.
Is there any question?
Yes.
So how like, we know some like building codes or something, adapt like ACI code, adapt by reference, adapt like Astm by reference. But we have like repeated standard now. Both have capacity, Astm, ISO, and when you go to the website of SASO, more than 20 times. I know that they are repeated but different names.
Yeah.
Your experience, how do you collaborate in this way?
I agree with you 100%. Each committee that has been set up for a reason. ASTM is basically a private organization. It's funded by industry in the US, and they follow their interests. They produce documents, and they have research-related work which develop those documents. ISO is supported because internationally the world wants a fully clear ISO standard, which is signed by everyone. Now, ISO does not have the same capability of doing research on every aspect. So what do? They go and adopt, with agreement of the countries, they go and adopt, for example, ASTM on one, BSI on another, and you're right, they are similar. Now, SASO comes along for a particular industry. They look at which one they think is going to be relevant to their own local industry. They may change a few lines because they're allowed to do that. But they would follow, for example, ISO. Why would they follow ISO? Because the trader from abroad wants to know that they're dealing with ISO. They don't know what the SASO level is. So these standard bodies have started, and mainly more for inspection and making sure that this is being properly applied. These standards are more important. Most of the standards are very similar. The detail you have to be able to read through to see what the differences are. You also have to know what your supplier or what your person who wants to buy, what they want. So if they want ISO, you have to do ISO. Whether you have a SASO showing it, it doesn't make a difference. But most of them are really trying to act in a conservative, safe way. Whether you follow one or the other, it probably doesn't make much difference. The difference is how it is acceptable between the two trading partners. And usually ASTM or ISO or ASME are more acceptable than many others because they've got history of, or BSI. Historically, they've accepted it. But in terms of quality, I don't think that there is a big difference. The national ones will make changes because they know what is involved nationally. So there could be small changes, but the main content should not be different. Because otherwise, you're disagreeing with another standard. And the important one was consensus. All these standards have to have some consensus. They have to have a main agreement between each other. So I wouldn't worry about the words adopting which one. You have to see what the trade is going to dictate to you. If somebody wants it in terms of ASME, you must follow ASME because you want to make the trade. And they're familiar with ASME. But if someone else is happy with SASO, you follow SASO. Both of them are, if they've taken due care, should be the same. Does that answer the question? There's no clear, they're all good. I'm saying if they've adopted it officially, they're all good. Yeah. 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 Yes, because they can adopt ISO and put it into there. Yeah, doesn't matter. They would adopt, for example, ISO. In some cases, it would be exactly the same. In some cases, there may be some changes. So both are acceptable because there's consensus. They're not going to follow a completely different route. If SASO comes up with a particular work, which is very different in their directions to ISO, ISO will come to SASO and say, why are you deciding this? There must be a reason. They may change. They're all trying to be similar in techniques. Because techniques are changing, one improves better, so everyone follows that one. The other one improves better, they follow that one. There's no 100%. So when you see 20,000, it doesn't matter. If one of them relates to your trade, to your work, you follow it. But if you're trying to sell the cement to some other country and they say, oh, we don't want SASO, we want ISO, you go and follow ISO. They're not much different. It's the same. In the UK, BSI is there, but I can't tell my Japanese counterpart, I will only send you in BSI standard. He has to accept it. If he says, no, I want ASME, you follow ASME. That's why they're trying to make equal playing field and get all these standards very similar. And in fact, they are. They're getting more and more equal. So even country standards, though, you can say they're ISO standards.
Okay, then we'll take two more questions. I'll give the chance for the sister if they are interested. Okay. Does anyone have a question?
Thank you for your presentation. I have really just one question, if you don't mind. You have mentioned that we are not going to be 100% safe anywhere, or any organization has 100%. Is there any specific percentage about the safety of the organization or the reducing the failure of the system recently?
At the moment, standards follow safety case rules. For example, they have a minimum level below which they're quite sure from either from results or data that this is safe enough specifically. For example, if your loading is on a component in a certain case, such and such, you would have a safety level above which you mustn't go. That is very specific, deterministic approach. What you're saying is, even in these deterministic approach, there's a case that you could have failure because there's always a chance of failure. There's a probabilistic approach which says that in any industry, if you do a full risk assessment, if following actual rules, there's a chance that something will happen. That assessment can be done by risk assessors internally or externally, but standards don't usually follow that. Standards are very specific about limitations of loading, conditions, etc. We are trying to introduce probability assessments to say, for example, you must overall work out that the chance of your failure of your plant is 10 to the minus 5. Or in nuclear case, 10 to the minus 7. So 1 in 100,000, or 1 in 10 million. Both these aspects are not in standards and are still not acceptable. But I see that the direction is towards that. Because even in a nuclear case, statistically, every 10 years something is going to happen. The level of that danger may be small or may be large, but it's going to happen, even though you followed every rule, every condition. So that part is not in standards. Standards are much more specific and deterministic. But it doesn't tell you 100% that you're going to be 100% sure of failure or non-failure.
Okay, I think we should close up. Yeah, okay.
I want to ask about the units, how to solve the problem of the units. You see that some standard go with the US SI unit,
Yeah.
some of it with this imperial unit. I know that UK in the past use inch unit,
Yeah.
and they transfer.
They
to,
changed
yeah,
in the
yeah.
70s, yeah.
Especially as example for the pipe.
Yeah,
Now we have a problem in Saudi Arabia. We use both.
yeah, yeah.
International and inch unit.
Yeah. I mean, this
So
is
how
a
to solve
major... Sorry, did you finish? Have you finished?
Yes.
Yeah. But this is a major mistake or error that the US made when they decided to keep imperial units. But as you say, either the customer is king or the guy who's only got that equipment is king. You have to follow what they... if they're using imperial, it's impossible not to have otherwise. So SI units should be adopted by everyone. US, in fact, the industry, because they know many countries have SI, they do produce in terms of SI, but there are still some industries there which still keep to the... We have problems in doing assessments, analysis. You have to do it in 2 units, in pounds per square inch and kilograms. So it's something that's... It's an anomaly, but it's something that you have to do. We can't get away from it. And there are always problems associated with that.
Then now we should close up. We'd like to thank everybody for coming and participating, and also like to thank Neikhbin for this valuable presentation. And there's something to present to you. Could you please come forward?
Thank you very much. Thank you very much.
Thank you. Thank you. Very interested. We wish you the best and thank you for the information. And we will work together.
Yeah.
Mohammed Zakzak from the EU delegation. Okay. I'll be very grateful
في مجال تعطيني بس